So let's see now an example to see where and how to write these queries and these properties. We'll take our example, which is intelligent light controls.
As you know, this example has two timed automata. The first one is the light or the lamp, and the second one it's the user.
The lamp have 1 o'clock, it's X clock, and we have associational. So we want to verify the value of X. What the value of X, for example, in general, and what the value of X in some states. So how we can write this query? So first of all, if to write the query, we should go to the verifier, and then in this query we can write our query, and then we to check either this query is satisfied or not, just press check. So it's very simple. You just go and write your query and then check either it is satisfied or not. If you want to add more, one more query, you just also add a query and then write your query. So let's go and see how to write this query. So for example, if you want to write the query, search this query. So first, what's meaning this query? Here we ask about the value of X. Is it here we ask about the value of X. Is it greater than 0? But what's mean this two symbol? That mean all the time in all state. So is the value of X is greater than 0 all times in all state? Because as you know, these quantifiers mean all, and this is mean always on all state, always in all state. So what do you think the result of this formula or this query? So the second query, let's go 1 or 2. The second query is the system free lock? So once you write this one, that means is the system free lock in on state? So let's see. Let's go now to Uppaal and write. So let's go. So let's go now and open our example, which light. So this is the example. We just want to go to the query and write one query. We should go to this place, insert, and then go to this place. So we want to write in all states. We want to ask about X. Is it greater than 0 or not? So want to check this formula, just check. The result here, they say not satisfied. Why not satisfied? Actually not satisfied because here we ask, is the value of X, it's always, yeah, it's always greater than 0? Of course not. Sometimes it's greater than 0. Actually, most of the time it's greater than 0, but many times it's 0. So we should do add equal and check. So here it's true or satisfied because the value of X is greater than 0 or equal to 0. So here this is the first query, and very simple query. How to write this query? Just as you know, this is quantifier. We should know what's meaning. That's mean in all state, in all that is X is more than 0. So the result here satisfied. So if we take the second query, which is in on, the same in on state, is the system free deadlock, free deadlock, not free deadlock, because that means there is some deadlock in some state. That means in maybe we reach some state and we cannot go to the next state because no transition to the next state. So if we go back to this another example here, if we write the existing, this is some existing in existing, this E in existing, or in existing path, the light one, which is the process is in state light. The process light one, it can be in this state, in state light. That means in we have here this process light, for example, as we say, we have this is light one, for example. Is it the same light one, which is our process? Can this light one reach to light? So here the question, or here is the query. So let's see this, what the result of this. So in order to add, we should do just insert, and then we add our query. So we check. So it's satisfied. Actually, first is in existing. First, if you say in all, maybe it will not be true. So here in existing, but the light will be in this state. I mean, the light one will reach state light. So how we can we make it unsatisfied? To be unsatisfied, actually, we should change. Maybe you can add a guard here to not allow user or not allow the system to go to light state. So maybe you can add here condition x, for example, should be equal to 10, for example, or y should be equal to 10, and then we go and declare y into y equal to 0. So in this case, now y it's 0, but we ask here, we put as a guard y equal to 10. That means we will stay here. That means there is no transition from off to light. That means this system will not reach light. So we check this now. It was true, it was satisfied. If we change now, so unsatisfied because there is no transition. There is no transition from off to light. So we see the meaning of the other example. So here, is it possible to reach the same example, to reach light, the process light to be in light, and in the same time x is equal more than 3. So this is another query. We can write two, we combine two conditions. And the same thing here, this is actually it's imply. It's also can be used something like and, but it's different. That if this is true, this is will be implemented. So if x less than 3, we can come to the state light, right? That means if x is 3, thus we go to the light. Otherwise, not similar to and. If this and this. Now this is if x is less than 3, so light will reach